In this lesson, we will start with configuring OSPF on a Cisco router. Then we will learn about its different components such as link state database, router ID, wildcard mask. Then we will analyze the information stored in the router LSA. All the routers and PCs in this network have been configured with the IP addresses correctly. They are up and running. Now we need to configure OSPF on IT LiveSkill Router 1. The first step to configure OSPF is to enable OSPF process. In order to do that, at the router configuration mode, we issue the command router OSPF and then we provide the process number, then hit enter. After that, we X out this and issue the command show IP OSPF database and hit enter to verify the link state database. Let's do it on IT LiveSkill Router 1. Here we are at the private mode. Let's issue the command show IP interface brief and hit enter. As you can see, the interfaces E20 and E21 have been configured with the IP addresses correctly and their status are up and up. So it is ready for us to enable the OSPF process. Let's go to the configuration mode and issue the command router OSPF 1, then hit enter, and then X out of this and issue the command show IP OSPF database, then hit enter. As you can see, after we enable OSPF process, the router pick up an ID to identify itself for the process, and it also create an empty link state database. So how an OSPF router picks up its own router ID? As you may know, OSPF router ID is a 32-bit number and it must be unique in entire OSPF network. When a Cisco router reloads and brings up the OSPF process, it selects its router ID by the following orders. First, it will pick up the router ID value configured in OSPF subcommand. If it's not configured, then it will pick up the highest IP address of a loopback interface with the up status. If there is no loopback interface, then it will pick up the highest IP address of a physical interface with at least up and down status, and the router will not change its router ID until the OSPF process gets reloaded. Now let's look at IT LiveSkill Router 1 and assume there's no router ID value configured and there is no loopback interface. So the router will pick up this IP address as its router ID because this IP address is greater than this IP address. Now if we configure the loopback interface and assign an IP address to it and make it in up status, the router will not change its router ID. However, if we reboot the router, then the router will pick up the IP address of the loopback interface, even though the IP address of the loopback interface is less than the IP addresses configured on the physical interfaces. Now, if we configure the router ID command and reload the OSPF process, then the router will pick up the value configured in the router ID command instead. One important thing to note is that if none of these parameters exist, then the router will generate this error message saying that it cannot pick up a router ID and will not enable OSPF process. To configure router ID, we need to go to the configuration mode and issue the command router OSPF, then we provide the process number, then hit enter. It will bring us into the router configuration mode. We need to issue the command router ID, then we provide the ID value, then hit enter. To make it picks up the new value configured in the router ID command, we need to go to the private mode and issue the command clear IP OSPF process, then hit enter. Let's do it in IT Life Skill Router 1. Here we are at the private mode. We need to issue the command show IP OSPF database, then hit enter. As you can see, currently it's pick up the ID value based on the physical IP address of the router. Then we need to go to the configuration mode and issue the command router OSPF 1, then hit enter. Then we need to issue the command router-id 1.1.1.1, then hit enter. Then we exit out this and issue the command clear IP OSPF process and say yes and hit enter. Now let's issue the command show IP OSPF database, then hit enter. As you can see, it picks up the value that we configure in the router ID command after we reload the OSPF process. Before enabling OSPF on routers interfaces, we need to understand whitecost or whitecost mask. Whitecost is used to filter a range of IP addresses. An IP range written in whitecost has a format network ID, then whitecost mask. Whitecost has 4 octets. Each octet has 8 bits represented in decimal from 0 to 255. Where 0 means exact match and a number means a range of IP addresses that match. A whitecost can be thought of as an inverted subnet mask. Therefore, it is easy to find the whitecost by subtracting a subnet mask from 255.255.255.255. For example, if we have the subnet mask 255.255.255.248, we can find the whitecost mask by subtracting each octet from 255, and in this case we have the whitecost mask is 0.0.0.7. Therefore, the subnet 10.0.0.0 with the subnet mask 255.255.255.248 written in whitecost format will be 10.0.0.0 with the whitecost 0.0.0.7, which gives us the range of IP from 10.0.0.0 to 10.0.0.7. In our network diagram, the whitecost must to match only the interface E21 will be 10.0.0.1 with the whitecost 0.0.0.0, which matches exactly this IP address. If we want to match both interfaces E20 and E21, the whitecost mask will have the network ID 10.0.0.0 and the whitecost is 0.0.15.255. To enable OSPF on network interfaces, we need to go to the configuration mode of the router, then issue the command router OSPF, then we provide the process number, then hit enter. It will bring us into the router configuration mode, then we issue the command network, then we provide the network ID and the whitecost mask, then the area that we want to put the interfaces in, then hit enter. The network command here will cause OSPF to run on any interfaces configured with IP addresses in the range from 10.0.0.0 to 10.0.15.255 and put the interfaces in the area 0. Let's do it in IT Life Skill Router 1. Let's go to the configuration mode and then issue the command router OSPF 1, then hit enter. Then we issue the command network 10.0.0.0 and the wildcard 0.0.15.255 and the error is area 0. Then hit enter. Now let's X out this and verify our configuration. Show IP OSPF interface brief, then hit enter. This command tells us which interfaces are running OSPF, and in this case it is running on the interface E21 and E20. Everything looks good. Let's now check the link state database after we enable OSPF on router's interfaces. In order to do that, at the router private mode, we issue the command show IP OSPF database, then hit enter. To verify the detail of the router LSA, we need to issue the command show IP OSPF database router, then hit enter. Let's do it on IT Life Skill Router 1. Here we are at the private mode. We need to issue the command show IP OSPF database, then hit enter. As you can see, after we enable OSPF on the router's interfaces, we now have the router LSA created in the link state database, and it tells us that the router 1 is a router that created the router LSA, and router 1 has 2 links. Now let's take a look at the detail of the router LSA by issuing the command show IP OSPF database router, then hit enter. As you can see, the router LSA, it describes the router ID on the process that we created, and it is for area 0, and it tells us the router that created the router LSA, and the router has 2 links. Now let's take a look at the 2 links. The first link has the network ID 10.0.0.0 and the subnet mask 255.255.255.248, and the second link has the network ID 10.0.10.0 and the subnet mask is 255.255.255.0. Let's use this network diagram to see how router LSA describes the network. First of all, it describes the router that created the router LSA, and it is for the area 0. And it describes the first link from IT Life Skill Router 1 to IT Life Skill Switch 1. And it describes the second link from IT Life Skill Router 1 to PC1. Let's read the keynotes for this lesson. This is the end of this lesson. If you have any questions, please put it in the comment section. Thank you very much for watching.